All right, so today, first the class has a question on page 104, which is the 2.2 part 1 assignment. There we go. So this is page 104, and number 33 is the one they wanted me to look at. So number 33 has a factored function, f of x, written as x times x plus 4 times the quantity x minus 1's quantity is squared. And this is one of those questions where they want you to do 1,000 things. Apply the lead term test, determine how many zeros, and state the multiplicity, and then find a few additional points, and then graph the function. So for me, I was too lazy to literally go find additional points, so I just kind of fudged in a graph. But you guys had a graphing calculator and you're near access, so I would expect you to go through and find a couple extra points. But let's talk about the lead term test first, guys. If you look at just the lead terms of each of these quantities, this one you got to be a little careful on, because remember this quantity is being squared. So it's like you have an x times another x times another x squared. So your lead term is going to be 1, x to the 4th. So you have an even degree with a positive lead coefficient, positive 1. So your n's are going to be doing this. Whoops. That doesn't look like anything. Try again. There we go. So I don't know exactly what's going on in the middle yet, but I know the n's look like that. So when they say like apply the lead term test, they're looking for that sort of a business. Now, this particular example didn't have any lead coefficients other than 1s, so you do still have to be careful about lead coefficients when you're doing this lead term test in other questions. Like for instance, I think I assigned number 37. You got to be a little careful on that one. So part B, they say talk about the zeros and state any multiplicities. So these are already in factored form. This is already in factored form. So for part B, you take each of your factors and you set them equal to 0. So x equals 0, x plus 4 equals 0, and x minus 1 equals 0. But this one here, remember, is squared. So that means that solution showing up how many times now? 2. So here, x equals 0 is a 0. X equals negative 4 is another 0. And both of these showed up once, so if you wanted to, you could write multiplicity 1 on each of these. But I'm just going to, assume for my class that if you don't write anything about multiplicity, I'm going to assume you meant it to be multiplicity 1. But here, you're going to get x equals positive 1. And you guys just told me that shows up twice, so that has multiplicity 2. So a little refresher from last week, if it has odd multiplicity, it's going to go through and intercept the x-axis. If it has even multiplicity, it's going to bounce off. So this is where I attempt to graph, and y'all get a little giggle on a Monday morning. It says to find additional points. You would be on your calculator and you'd find additional points that way, guys. Like a y-intercept is always a nice one to find. We already have all the x-intercepts, so here goes. So x equals negative 4. Totally. Negative 4 right there. And then positive 1 and 0. So the issue that we're going to run into is that this one at positive 1, remember, it's going to bounce off. So I have to kind of envision what this looks like. You guys have a $150 machine that graphs for you, so if you weren't sure, you would just graph it. But remember, the ends are supposed to go up. So I know this comes through, and then I don't really know how far it goes down, and I don't really care. But then it crosses through at 0, and then this is the one where it's going to bounce. So I don't... Hey, that was pretty good. I'm going to call that a win. I don't know exactly what it looks like. That minimum is a mystery to me, and so is that little maximum bump, but it's something like that. The important thing there is that you knew because of the multiplicity 2, it was going to bounce off of x equals 1. Alrighty. Anything else? Oh, I even wrote a note to you in my key that I totally nailed that question. Good job, Abruzzo. I didn't, by the way. It's not even close. All right. No more questions on homework. Good. Let's warm up. This guy. You don't have to take out anything quite yet. You will work on worksheet 4 with me in the notes. But for now, let's warm up by squaring both sides of this. I am not worried about the left side here. You guys are doing just fine squaring a radical. But over here on the right side, some of you forgot what this meant. This is the quantity square root of x plus 4 times another square root of x plus 4. So I suggest you guys take the effort to write it twice and then go through and FOIL this out. So square root of x times square root of x is x. Thank you. And then you have plus 4 square roots of x plus another 4 square roots of x, so you have 8 square roots of x. And then 4 times 4 is 16. Now, bad news is we still have a radical in our question, but the good news is there's only one, so as long as you get him isolated, mostly isolated, then you can go back and square both sides again. So I'm going to subtract the x. Oh, this is a fun one. I'm also going to subtract the 16. Oh boy, did I do something weird? Oh, this is going to be weird. All right, 3x minus 3 equals 8 times the square root of x. Now this is where you could do one of two things. You could go through and divide everything by an 8. And you can have 3/8 x minus 3/8. And then you can go square that quantity. Or we could not do that, and we could just square right now. That's what I'm going to do. So this is still going to be like a foiling question. It's 3x minus 3 times another 3x minus 3. So 9x squared, let's see, minus 6, no, minus, hello. I really should write this out, I guess. That's minus 9 minus another 9, so minus 18x, and then plus 9. Now what's going on over here, guys? You're squaring both the 8 and the radical. So this 8 becomes a 64x, because the square root of the square cancel, just an x. It is a quadratic, and it's an ugly one. All right, I'm done doing mental math. It's Monday. Can someone please take negative 18 and subtract 64 for me? Is it that? If it's not that, we're in trouble, because that means you didn't even look at it.
What's 8 4?
What?
8 4s and the one on top.
I know, I'm asking you to confirm. It's Monday. With your eyes. Now, I do have a quadratic. I got bad news. There's no common factor. I kind of hoped I could divide everything by 9, and turns out no, I can't. This one probably does factor, but it's Monday, and I don't really feel like factoring right now. Fine. You want to factor? What do you want for 9 and 9? Okay, very good. Even on a Monday, look at you. He says we need a really big number in the middle term. So a 9 would be a smart choice. So I'm assuming you're going to go the same direction with this positive 9 on the end.
Yep.
And you're going to put the 9 over here, and you're going to make them both negative 9 and negative 1. Does that work? Negative 81 plus negative 1 is negative 82. All right, I guess that wasn't that bad of a factoring question. My bad. All right, x equals 1/9 and x equals 9. So after all that, we're done, right? We get to box in our answers and walk away? No, of course not. You got to go way back to the beginning of the problem and go, did they check? So the easiest one for me to check is x equals 9, so I'm going to hurry up and check that one. If I plug in a 9, I get 4 times 9 is 36 plus 13, which is the square root of 49. And then over on this side, it's the square root of 9 plus 4, which is 3 plus 4. Okay, guys, 7 equals 7. Now, do you know what some of your classmates did on the last test? They wrote down at the very end of the problem, x equals 7. Because that was their checked answer. Oh, that made my heart break a little, guys. The answer to x was not 7. Go back. What was the answer to x we just plugged in? 9. Yeah, this was an answer for x. So that one checked out. Now we're supposed to go back and check the 1/9. Okay, so same problem, except this time I'm plugging in a 1/9. Gross. 4 times 1/9 would be 4/9 plus 13. Okay, I am not doing this in my head. Please someone type these fractions for me. Say what? Okay, that's the square root of 121 over 9. That's nice. Equals the square root of 1/9 and then plus 4 out of the square root. Okay, so that's 1/3 plus 4. That would be 13/3. And, right? Yeah? No one has checked an ounce of my math in the last 20 seconds. Try again. Yeah. Okay, and this is an 11 over 3, and does 11 over 3 match up with a 13 over 3? No. So we're going to go, you are extraneous. And then 4 years later, we have our answer. Okay. There's one like that coming up on your next test. So best wishes to you all. All right. There's also one like this coming up on a test. Now, Mrs. Hoffbar and I just had a little powwow this morning. We decided that we are going to retest transformations, but we're going to stick it on the next test. So not the one that's coming up on next Tuesday, but the one that's coming up next Friday. Yes, you heard me. You have 2 tests next week. But the second one is no calculator.
Wow.
Wow, this gets better and better. All right, so we were trying to be nice to you. We knew we wanted to retest transformations. So rather than making Tuesday's test incredibly lengthy and fun, we took transformations off of that test and stuck it on the back of Friday's teeny tiny test, and then made Friday's test just slightly longer than it was going to be. So you're still covering the same amount of material. We're just giving you 2 kind of average days rather than 1 horrible day and 1 nice day. Got it? Look at those faces. Oh, internet, you can't even see these faces. All right, question. When does this get applied? First or last? Fight. You're saying different things. Go. First? First? Okay, why is it first? There's no parentheses to distribute it to everybody, which means it's going to happen right away on the function. So, in order, you are going to reflect over which axis, first of all? When it's in front of the function like that? The x-axis. Yes, this is a vertical reflection. And then we're going to shift everything up 4. Those of you who are thinking we were supposed to do the reflection at the end of the problem, you would have thusly shifted everything down 4 if you did that. So be careful. All right, so if I were to do it in that order, let's see. I'm going to take this ordered pair, and I reflect it over the x-axis. That's very boring. And then I'm going to shift it up 4 units. And then I'm going to take this ordered pair, kind of. I'm going to reflect it over the x-axis, so it's like down here. And then I'm going to shift everything up 4 units. Here we go. 1, 2, 3, 4. Oh, switch colors. Did I count right? I didn't go enough? Oh, jeez. All right. So if I reflect, I'm down here at like -3 point whatever. I think I'm okay where I'm at. All right. And then I'm going to take this point. I'm going to reflect it over the x-axis. So it's like down here. And then I'm going to move up 4 units. 1, 2, 3, 4. And then I'm going to play connect the dots and totally miss all my points because I can't draw. Sweet. That's the most beautiful triangle. Oh, lordy. All right. Anywho, there's that. So then, is this different? Oh, yes. Okay. Someone tell me how they interpret this question. First doing what? Up 4. And then what would be your second step? Reflect over x. Agreed. Does anybody view this differently? Because there is another way to interpret this question. Abruzzo does this. So if that's how I'm interpreting it, what is my order of transformation? First reflect, and then down 4. So both of these are acceptable, and you end up graphing the same triangle. Now it turns out I can't graph a triangle, so I'm going to not do that step. But just be careful about the order of transformations. You have to kind of make a decision on your own side, like, okay, if there's parentheses around things, am I okay with that? Like me personally, I'm not. I screw it up every time, and that's why I choose to distribute the negative through. Okay? All right. You find worksheet 4? And everyone has a working graphing calculator? Because we're going to do a lot of graphing calculator work today. Now, when I go and show you my emulator calculator, I have already entered all the data from our entire lesson today because I'm so stinking slow. So you're going to see my data is like everywhere on my calculator, so you just decide where you want to put your data when we enter it, and it might not match up with mine exactly, and that's okay. So I'm going to give you data points, and we're going to create scatter plots very similarly to what we used to do for linear regression, but now that we are no longer talking about linear functions, we're going to expand it to other types of regression. So in your plots, in your lists, we need to enter our data. Mine is in list 1 and list 2. So decide where you want to put your data, but mine went to list 1 and list 2. If you're working at home, you're going to pause the video and enter your data by going to Stat and then Edit. And again, you're going to see a whole bunch of data in mine because I'm all set up for the whole day. All right, so your data is in list 1 and list 2, and what I want to do first today is just to explore your scatter plot. So go to y equals and make sure that any existing functions are deleted from y1 and y2 and so on. And then we need to set up our plot to plot accordingly. So I'm going to go to second y equals, which is our stat plot menu, and I'm going to open up plot number 1. And mine was turned off, so I'm going to turn it on. If you were like in default mode still, it probably chose a scatter plot, which is what I want. And think about where you put your data. My data for X was in list 1 and list 2 was Y, so I'm going to leave it saying that. You could choose to change the way your marks look, and you can choose to change your color if you're feeling festive today. Otherwise, we need to graph this. Now, if I hit graph right now, it's going to graph whatever the previous window was, and I doubt it's appropriate for this problem. So I'm going to cheat and do zoom stat and hope that that worked out. And it did. What kind of shape does that look like if you squint? Does it kind of look like a parabola who's been reflected and shifted up somehow, probably over to the right a little bit? Okay. So the good news is you don't have to find the equation. Your calculator is going to find it for you. Remember how we did linear regression before? Well, now you're going to do what's called quadratic regression. So go back to our stat menu. Okay, in the stat menu this time, because you've already edited your data, you're going to calculate something now. And we kept choosing linear regression a couple chapters ago, but now we're looking at a nonlinear function. So we're going to go with, we think it's a quadratic equation, so choose quadratic regression. So for our newer calculators, it's going to ask you where's your data. It's going to default list 1, list 2, so later on I'm going to have to change that, but for now I'm good. And then I would like to store the equation into y1. Leave frequency lists empty. You don't have one of those. Who remembers where I pull up y1 though? It's hidden oddly. You go vars, yep. And then over to y varies. It's a function, y1. And then command to calculate. Boom. So that guy looks familiar. Quadratic standard form, ax squared plus bx plus c. It's going to tell you who your a, b, and c coefficients are. Fantastic. I need you to jot that information down on your paper then. And let's round to the nearest thousandth. So 3 decimal places, please. Did everyone get these same values for A, B, and C? Or just me? So far so good? Alright, that's good. Now it does ask about correlation coefficient. Oh, wah wah. I forgot to make sure you guys turn that on. Remember how you have to sometimes go to diagnostics on, especially if your calculator has been reset? So I have a feeling some of us, and possibly me, yep, I don't have correlation coefficient. Because I never went through that step at the beginning. I must have reset my calculator at some point to turn them on. Do you remember where we go to turn the diagnostics on? Easiest way to go is go to the catalog. Very good. So catalog is right above 0. And then you can either scroll down for, whoops, not that. You can either scroll down forever to the D's, or you can do alpha lock. And then get down to the D. Let's see where we at. And then diagnostics on. And you're going to choose it and then hit enter again to actually go through. Oops, come back. So choose it. Turn the, oh man. Remember that stupid 0 I had? I gotta delete that. Okay, now on. So now, unfortunately, I do have to go through those steps again about stat, calc. And I think I don't have to store it again because I think it's still stored in Y1 from my last go around. So I'm going to skip that step and hope for the best. There we go. Okay. So go ahead and just jot down 0.99. Yeah, what's up? All right, so now they're going to have you take your information, you just found that equation, and they want you to predict the flow rate at 10.5 hours. So the 10.5 hours is your variable x. This is another way of them saying plug in 10.5 for x. Now, you're welcome to manually plug in 10.5 into the function you just got, but remember the function was truncated quite a bit, rounded. So ideally, I'm going to, you know what, let's just graph. If you hit the trace key, right now it's stuck on the scatter plot, but if you push the up arrow, it'll hop to your next function, which is y1. And then I'm just going to manually type 10.5 right here and see if that works. Yeah, that worked out. So that was kind of a trick because there's two functions technically being plotted, the scatter plot plus the y1 function. So it's going to default to like the first one that it's near, so it defaulted to the scatter plot. If you ever want to switch to your next function, whether it be y1 or y2 or y3, you can just hit the up and down arrow to hop between the functions. Anywho, I got 0.17 when I round it. But notice in the chart, it says in hundreds of liters per hour. So you have to multiply that number by 100 for the next answer. So it's 0.17 here, so multiplying it by 100 would be 17 liters per hour. Okay, so this next question, they still want you to use your function and still use the calculator. This time they want you to predict when the flow rate was 1,000 liters per hour. So this is kind of confusing because remember the function itself is per 100 liters per hour. So you have to divide this by 100, which is why they're getting y equals 10. And for a lot of kids, they like to just trace and figure out when it hits 10, but there's a much more efficient way to do this, guys. If you go to your calculator, and in y2, you type 10. You're going to see where they intersect. And finding an intersection point is a lot easier than tracing for the rest of your life. So intersection is found by going to your calc menu, choosing intersect. Now notice he is on the curve, the quadratic curve, so hit enter. And then it's going to hop to y2, hit enter. And then it says, is this your guess? Good enough, hit enter. And turns out it's at about 8.5 seconds. Or hours, excuse me, 8.5 hours. Labels, they're important. All right, so about 8.5. Okay, very good, very good. So hopefully we're getting a little more comfy with our calculator. We are going to do a lot more with calculators in the upcoming future. All right, example 2. You're going to need to get this data entered into 2 of your lists. Just be careful where you put them. If you want to empty out list 1 and list 2 and replace them with this data, that's fine. I will warn you if you're trying to stay exactly with whatever my screen says. My data is already existing in list 3 and in list 4. So you need to pause the video and get your data entered. So I had my data entered into list 3 and list 4 for this problem. And remember, all your old stuff from the previous problem is still sitting there in y1. So first thing we need to do is clear out the original function from the previous problem that they put into y1. And then remember, add that other y equals 10 that we got out of there. And then what I did for setting up my stat plots, I turned off plot 1. That was the list 2, list 1, list 2 plot. And then I created plot 2, except it's still wrong. Let me go fix that. It's going to want to plot list 3 and list 4. So let's see if I can get it right finally. List 4. There we go. All right, so wherever your data is, make sure that that plot that you're about to look at is turned on and it has the right input and output lists. So for me, that's list 3, list 4, and I want to zoom stat again. It's going to have to readjust the window for this new data. So zoom 9. Oh, lovely. Is that what yours looks like? Yours isn't graphing at all? Okay, this tells me I have something wrong typed in. All right, let's go find it. Find it for me. What's wrong? 0.39. You already found it. Where am I? Down here? It's supposed to be... Oh, the Y. Haha, that'll do it. All right, so this is a good example of Bruzo has a problem. What is this supposed to be? 60,000. Oh, yeah. 267. So, changing my data clearly is going to have an effect. And I'm going to have to readjust the zoom to my new data. So zoom 9 again. Is that what you got? Okay, that's better. And that's why we do want to take the chance to look at your scatter plot, because if we've all done this before where you had one thing entered wrong in your data, and like I can't see what you guys entered on your data, I just assume you had a mistype because your stuff comes out really weird, but this will stop me from doing something like that on a test. So, for you guys, you might look at this and go, oh, it kind of looks like part of a quadratic, and this is kind of the challenge for math. We have multiple types of regression. So for us at the pre-calc level, oftentimes what's going to happen is I'm just going to tell you what kind of regression to use. So this time I'm going to tell you to use what's called a power regression. A power regression would be like you're graphing a part of a polynomial. So go to Stat Calc, and this time, if you keep scrolling down the list, you're going to see it says like capital PWR stands for power. Oh, there we go. So on my list, it's A. Choose that one. Now remember, my data is not in list 1 and list 2. Mine's in list 3 and list 4, so I'm going to have to change that. And I would like to store it into Y1, so I'm going to go to varies, Y varies, function, Y1. There we go. Calculate. And remember, diagnostics were already turned on, so I'm not going to have to worry about doing that again today. Okay. So power regression formula, they give you the generic formula they're using. It's A times X to some power. And then this is the information that you're supposed to plug in. This time you're going to use the correlation coefficient there at the bottom, which is a really nice fit, 0.99999. So really good job with the power regression. But you're going to need to write down the equation on your paper. So it does say round to the nearest thousandth. Keep that in mind. So we have 367.323 times X is your base, and it's being raised to the 1.501 power. So it's an exponential, I'm sorry, no, it's a power function, excuse me, it's a power function, a really obscure power function, because we don't usually have polynomials of degree 1.501, but they do exist, especially in real life math, where nothing's pretty. And the correlation coefficient was like a bunch of 0.9s, wasn't it? I'll just write that down. Sounds good. I think it was even more than that. I think it was like 8, 9 after it even, so a super good fit is the answer. All right, I got one more for you. Entering more data. I'm going to enter my data into, it's already there, but list 5 and list 6. I need you to enter these guys into one of your X's and these into one of your Y's. You choose. Pause the video. So once your data is entered into 2 lists, mine are in list 5 and list 6, I do want to look at the scatter plot. So in Y equals, I'm going to clear out the last problem from Y1, and this time I either need to adjust the existing plot or turn on the appropriate plot. So for me, list 5 and 6 is plot 3. I'm going to turn this one on. There's a lot easier way to turn this on, by the way, guys. If you just go to Y equals, you can turn them on and off by toggling between hitting enter. So I'm just going to emphasize plot 3 and de-emphasize plot 2, excuse me. So zoom stat. Let's see. Anyone get something that vaguely resembles that when you zoom stat? Okay, good. So this time I don't have any data entered wrong. Go me. And that doesn't look like a quadratic, and it doesn't really look like what we just saw as far as a power function, but it does kind of resemble, I'm thinking like a cubic. So, and that just comes with experience with looking at functions. But like I said, for our level of pre-calc right now, I'll probably just tell you which regression to use. So why don't you, since it does say in our notes to use cubic regression, I believe, go down your list when you get to the regression options. Yep. Stat, calc, and this time choose cubic regression. Now remember where you put your data. My data is in list 5 and list 6. And I would like to store in Y1. All right, let's see the magic. Okay, so For cubic polynomials, they're going to give you an a, a b, a c, and a d, because cubic is one bigger than a quadratic, so it's going to give you 4 coefficients. But notice what's going on here, guys. It has negative 3.8, blah, 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 e negative 8. What does that mean? That's scientific notation for times 10 to the negative 8th power. So it's negative 0.00000003869, blah, 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 blah. So super tiny is the answer there. And this is kind of annoying, but they do actually want you to write that down. So, okay, here we go. The function is y equals negative point. I think that was 7 zeros. And I've kind of given up on where to round here, guys, because can we just all agree that this is really a 0 in this coefficient? Yeah, I think so. Let's just agree on that one. This next coefficient has a little scientific notation again, but if I write it as decimal, it's 0.00015 x squared minus, this one's not too bad, 0.136x. Oops, that's not a 6. And then the constant is a plus 167-ish. I don't know if it's that exact or not. So luckily, guys, this is already stored in your y1, so you don't have to do any work to predict the energy output when there's 800 calories. So what I'm going to do is I'm going to go to the graph. It's not a perfect fit, which we kind of already knew looking at the correlation coefficient. I didn't jot that one down. Did anyone jot down what the correlation coefficient was? The R? 0.98, which is like, okay, it's good. It's not perfect, that's for sure. But if we hit trace, right now it's on the scatter plot. Who remembers how I get to the function? So I'm off of the scatter plot. Just hit the up arrow. That works. So now you're on the other function. And then 800 calories is what they wanted. Okay, jot that number down. 136.45. Yep. Little cal. Okay, so here's what you're going to do for homework. On the blue sheet, you have a 2.2 Part 2 book assignment, and I think it stops at like number 67, and then it says plus the rest of worksheet 4B. So we ran out of time today. We're going to have to work on worksheet 4B tomorrow. So like don't touch worksheet 4B yet. Sorry. So what you're doing for homework tonight, look on your blue sheet, but it's the 2.2 Part 2 book assignment. So it's the same page, page 104, 105, whatever it is. But it starts off at number, what number does it start at? 43. All right, so 43 through, I think it stops at 67. Obviously not every question. It skips around. So it's a lot of calculator work on that book assignment, guys. If you still need to check a calculator out for me, please come see me, and I'll get you one.